Hello students, this is our next second session in the inheritance. So today we are going to cover a super keyword, its uses, and we'll talk about a very simple example of multi-level inheritance. How can we implement the multiple inheritance? And we'll talk about dynamic dispatch method. The basic concept of dynamic dispatch method has already been covered in my previous session. I'm just trying to introduce and correlate with this term, right? So first we'll talk about the super keyword, right? So there are a few things that you need to know about the super. Okay, super is basically a keyword, and so basically, what is it? What is a super? Super is a keyword. Okay, it is a keyword, and there are two uses, main uses of the super keyword. First one is uh, to invoke super class constructor, and next uses of the super keyword is to access a member. Okay, it could be a data member, a member function, access a member of superclass that has been hidden by members of subclass. So you might wonder that how subclass member can hide the members of superclass. So I'll tell you, I'll give you the example. Okay, so we'll first try to understand how to achieve the superclass, how to invoke the superclass constructor. Okay, so let us take the example. Suppose there is a class. Suppose there is a class called A, okay, and inside which there is a data member called int A, comma B, right? So you have got one initialization statement, void IP, okay, equals to int m, comma int n, right? So basically it should not be a void, it should be a constructor. So I'm trying to basically show you a demonstrative example of the first uses of the super keyword. Okay, so name of the constructor is A, so name of the class is A, so this is how I am going to implement the constructor part. So inside a constructor, I'm going to initialize the A with value m, and then initialize the value B by value n. So basically I'm trying to initialize it, right? Okay, so a very simple statement. And after that I can even display it also, but I'm not worried about displaying. Okay, fine. Okay, so this is first thing, right? Next, suppose I have got the another class, because I have to use the concept of superclass and subclass. So there is, say for example, there is a class B that extends class A. Okay, so basically A is a parent class and B is a child class. So in B, I may have got some additional data member C, right? Okay, C. Okay. So uh, okay, so okay, this is our example. So in B, I want to have a constructor. I want to have a constructor in B which takes three parameter int p comma int q comma int r, right? pqr, and inside which I am trying to invoke the superclass constructor. So B can invoke the class B constructor, can invoke this constructor, this superclass constructor, by using the keyword super. And then since there are two number of arguments in the superclass constructor, so you have to supply two arguments. So p and q are supplying. So this is one thing, and in addition to it, okay, suppose you want to initialize c equals to r. Okay, so you are trying to initialize c by r. So this is my first thing. Now I will have a main class. Okay, so it's class demo, right? So and there is a public static void main class PSVM. Okay, string args I'm not writing. You can assume it. Yeah. Okay. So inside which I am going to create a class called object of class A. Suppose how do I ob1 is the ob1 is the name of the object for the class A. New, yeah, A and empty parenthesis, not empty parenthesis. I'm going to supply two argument. So for example, 2 comma 3, right? So whenever this statement gets executed, whenever this statement gets executed, uh, 3, 2 and 3 will be replacing, will be initialized in the m and n respectively, and further m and n value will be initialized to a and b respectively, right? Okay, so this is all about the initializing the data member of class. But here we are talking about the superclass and subclass. Suppose I have got the another object. Okay, suppose I have got the another object B. Okay, I have got the another object B, and OB2 is the name of the object of class B, which extends A. New operator, and then here I will write 5 comma 6 comma 7. So now in that case what will happen is that 5 will go to P, and 6 will go to Q, and 7 will go to R. And furthermore, using this, okay, furthermore using this super, okay, using this statement, okay, uh, P, which is 5, will get to, will go to M, will go to M, okay, and similarly 7 6, which is going to Q, will go to N respectively for initialization of A and B respectively, and third, okay, your C will be initialized. So this is how I can invoke the superclass constructor. So with the help of the super keyword and the in the parenthesis, you supply the that number of argument that the super class constructor is demanding or requiring or defining, right? So this is one uses, right? Yeah. So that's why that I've written over here. Next uses that I'm going to use is how to access the members of the superclass that has been hidden by the members of subclass that I will talk about. So here members, it might be a data member or it might be a member functions. Okay, that I'm going to give you the example. Fine. Okay, so let's start. Suppose there is a class A. Suppose, yeah, suppose there is a class A, and inside which there is a variable called I, int I. So I is the variable pertaining to pertaining to parent class A. Suppose I have got another class B extends A, inside which you have got the variable again int I. So here I'm using purposely. Okay, so say for example there is a constructor, okay, B. Okay, there is a constructor B, or I can take help of some another example also. Yeah. Okay, not B. Okay, so let us initialize it. Instead of let's initialize with some value 10. Okay, and this is 20, right? I'm assuming I can initialize it. So now SOP. Okay, before that I'll have void disp, and then here I'll have SOP system.out.print and I. Okay, so I'm trying to print value of I. So when I try to print value of I, okay, since I want to display the value of I of this, but the name is same. See, the class B inherits the property of class A. So I will come over here also, this I and this I. But whenever I try to use for like computation or retrieval or accessing, since the name of the local variable, since the name is same, since the data member is same, so this I of A is hidden by this I because they are having the same name. Or in other words, this I will get highlighted rather than this I. Okay, or we can say also that this I of subclass is getting preference over this I of superclass. So this is the scenario. So when I try to display it, will display 20, but I want to display 10. So if you want to display 10, so you need to basically you need to basically hide this I and unhide this I. Okay, hide this I of B and unhide this IA. So that can be achieved with the help of the super keyword. So if you want to display 10 not 20, then you have to use super dot I. So if you use this, 10 will get displayed over here. Okay, 10 will get displayed over here. So here you are trying to, in this example, you are trying to basically unhide the variable, of the just unhide the variable immediate superclass, unhide the variable of immediate superclass. Okay, so that immediate superclass is very important because the main uses of super keyword is found or generally used for immediate superclass. Okay, so if there is multiple hierarchy, like for example A, B, and C, and you are trying to use the super keyword on C, then it will be impacting on the class B, not A. So immediate superclass, it will be using it. So this is the another second uses of the super keyword. Okay, I hope I made it clear. So we can have a look over here, the same example. So there is a class A, there are two variables X and Y, and there is a method, right? And there is a class B that extends A. So basically class B is a subclass and class A is a superclass or a parent class, and B is the child class extends A. And there is a variable X and Y wherein you can see that the first variable X is common to these both. Okay, so when B inherits this, so this X is also there with the class B and this X is also there with the class B. But whenever you try to use it, okay, whenever you try to use it, and due to this presence of this same variable name, the variable of superclass will be hidden, right? Will be hidden. So when you try to do SOP, so this X will display the value of this X pertaining to class B. But if you want to display the X of immediate superclass, then you have to use super dot X. So that's how you can print it. Okay, this is your second use. And third one is, as I told you, that you can use the super keyword not only to data member but also to the member functions. So say for example, there is a class A where there is a one method name is show. There's a class B, there's another method. Okay, so it might happen that the definition might be different. Okay, definition might be different. So there is a void show method of class B. Okay, so there is two show method in class B. Now you can select suppose you want to invoke this void show method of class A, which has already been overridden in class B. Then you can use the super keyword inside the show method of the inside B. So first, inside, suppose you want to invoke this. So in the first statement of the show method of class B, you need to have this super.show method. So because of the presence of the super.show method in the show method of class B, this method will be invoked. Okay, so this side is the common PSVM statements. So wherein there is an object of class B and there is a object of class B name is B underscore obj, and whenever you try to access whenever you try to access the obj.show, okay, so it will execute this first. This will execute. So one way is to have this in the first statement. Another way is like you can have the superclass reference variable and the object of the subclass, and then this. Okay, this is also using this also you can access this. So there are two ways. So, but this second method we have already seen it. This is an alternative, but so method also. So using super also you can do the same. Okay. So this first one is applicable to this uses of super keyword, and second is the alternative method. If you try to do this, okay, super dot, so it's not allowed directly. Okay. So next one is the how can we create the multi-level hierarchy. So multi-level hierarchy means, so next topic is multi-level hierarchy. Okay, sorry, multi-level inheritance. Multi-level inheritance means there is a class A. So there is a class A and there is a class B. Class B inherits the property of class A, and there is a class C, and class C inherits the property of class B. So basically, C contains both the features of A and B. So how can you implement it? Okay, so that can be implemented. There is a class A. I'll just show you the architecture, and there is one constructor. Say for example, uh, SOP. I'll write it system.out.println. Okay. Uh, this is a constructor. Okay, this is a constructor. Fine. So another, there is a class B. Okay, there should be a class B that inherits class A, and inside this there may be so many statements. Like a common statement may be a constructor, can be a constructor. So SOP semicolon, and this is B constructor, and the third one is class C extends B. Okay, B, middle one, right? Okay. So inside B, okay. So I will have a constructor. Again, same statement as SOP statement. This is C constructor, right? So this is all about the A, B, and C. Okay, fine. Okay. Now, having said this, okay, this is an example for multi-level hierarchy. So you can see this pertains to this, okay, and this pertains to this, and this pertains to this. Okay, so this is how you can implement the multi-level. Now, suppose there is another class, main class. I'm talking about main class. Okay, class demo. Okay, class demo. So this default constructor, it will be automatically invoked whenever you create the object of that class. Okay? So PSVM, okay, string args, I'm not writing it. And suppose you create the object of class C. Okay, C OB equals to new, okay, C. So when you create the object of this class C, okay, you need to note down one of the very important feature, that how this constructor invoke, because you all know that the default constructors are automatically invoked whenever an object is created. So when you create the object of class C, which is the lowermost, which is at lowermost level, then it will follow the pattern of invoking the superclass constructor and so on. Okay, so first, when your output of this program will be, first this will be displayed, then second this will be displayed, and third will this will be displayed, which means that whenever you create the object, okay, so the superclass constructor will be invoked first, and so on in a hierarchy. So if you see first in the output screen, first you will see this, and after that you will see this, and thirdly after you will see this. Okay, so that's what is stated. Now the constructor cannot be inherited by the subclass. Superclass constructor are called first whenever a constructor of subclass is invoked. So basically, whenever you create this, obviously it will invoke this. Okay, but you see that, okay, C has been derived from B, so it will go, the default constructor of B will be invoked now. Now whenever whenever it is trying to execute this statement, it understands that B is also inherited, B also inherits the A. So again the constructor from here it will go. Okay, now once it is there, okay, it's a base class, so it will get displayed first statement. So first statement will be this. Then after that, this statement will get executed, and after that, this statement will get executed. So that's the sequence, right? Okay. So next topic is the dynamic dispatch method. So this the main important aspect of my dynamic dispatch method has already been discussed in my last class session. So one of the importance of studying the inheritance is applying or implementing the runtime polymorphism, so which we can easily achieve with the help of the concept of method overriding and the superclass concept. Okay, superclass reference variable. Okay, so basically dynamic dispatch method, dynamic dispatch method. Dynamic method dispatch is a concept which uses the concept of method overriding and superclass reference variable to implement the runtime polymorphism rather than to implement polymorphism or overridden method to call overridden method at the runtime rather than compile time. So here I have written it is a mechanism by which a call to overridden method is resolved at the runtime. So this statement itself is an can also be called as a runtime polymorphism. Okay, so rather than compile time. So dynamic dispatch method is important because this is how Java implements runtime polymorphism. When an overridden method is called through a superclass reference variable, Java determines which version of method to execute based on the type of object being referenced at the time of call occurs. This determination is made at the runtime. Okay, so you easily understand with the example. Suppose there is a class A and there is a method called me. Okay, and inside which there is some statements. Okay, statement may be different in different methods. Okay, there is another class B that extends A and there is the same method as that of A, call me, but the implementation is different. Again, there is a class C extends class A. So this is an example of okay, this is an example of there is a class A. So B inherits A and C also inherits. So what kind of example? What kind of inheritance is it? It is hierarchical inheritance. So whatever it is, you will see it. So this is the scenario. So if this is the scenario, how can I invoke? How can I decide which call method to invoke at the runtime? Okay. So this is a main method. So I have created a three object with A, B, and C name with respect to class A, class B, and class A. So A is the object pertaining to class A. B is the object of class B. C is the object of class C. Okay. So now you can, if you want to invoke this method of class A, you can easily invoke A dot call me. If you want to invoke this method of class B, you can easily invoke B dot call me. Like that way you can do. But another way to use the but that way is the compile time polymorphism. Okay, so runtime polymorphism. So runtime polymorphism, you are using the concept of reference variable. We are using the concept of reference variable. Okay, so overridden concept, it's written over here. Call me. Empty parenthesis. All three are same, and implementation is different. So method overridden is done. Okay, so you have method overridden is done. Now superclass reference variable. Superclass reference variable means this. A is the superclass and R is the reference variable. So R can take the object of A also, B also, C also. So that's the power of superclass reference variable. Okay. So now when this statement gets executed, now this statement gets executed only at the runtime. So what R will hold is decided only during the runtime of the program while executing the program, because initialization statement gets executed during the execution time only. Okay. So R refers to the, so since A is the object of class A, so R can hold the object of class A. Okay, so R dot call me. So now until unless this statement gets executed, whatever you write doesn't mean anything. Okay, because you do not know at the compile time which call me it is invoking until unless this statement is executed. Once this statement gets executed during the runtime, at that point only the call me refers to the call me of A, because R is holding the object of class. Similarly, if you want to invoke the call me of B, it has to be initialized with the object of class B and so on. Okay. And so on. Now, if you have not used this, and rather than if you have used instead of this statement, if instead of this all from here to here, instead of this statement, if you have used A dot call me, B dot call me, C dot call me, now in that case, obviously the corresponding call me will be input, but there is no concept of polymorphism. Okay, runtime polymorphism. So, but here we are trying to implement the concept of runtime polymorphism. So this dispatching is generally decided during the runtime. That's why dynamic method dispatch. Okay. So that's all for today. Just a recap of it. We have used various uses of the super keyword. We have used how to create the multi-level hierarchy, and then try to understand how the constructor invoked. And with the help of the dynamic dispatch method, we have seen how to use the method overloading and how to use the superclass reference variable. Okay, thank you so much. If you have any questions, please do post.